The final thing we're going to look at is the possibility of tandem Hofmann eliminations. So that means we're going to do one right after the other. But this really is only a possibility if you have cyclic amines. And one thing I want you to keep in mind is I've only written one set of conditions here, but this set will do one Hofmann elimination. Then I'll have to add all of these reagents a second time to do a second Hofmann elimination. So once we do step 1 and 2, we methylate the nitrogen. So we end up with 2 methyl groups, a positive charge, and then our base is the hydroxide after step 2. From here, based on what you know about the regioselectivity, we have beta hydrogen to choose from right here and right here. Now, both of these happen to be secondary carbons, but if you think about the products you would get in each case, elimination here will give you a monosubstituted alkene. Elimination here will give you a disubstituted alkene. So we're going to stick with these protons to predict the first product. There's our electron pushing arrows. And I'm going to draw this so that I don't move things around too much. Here's our double bond we form. And then I have the dimethylamine group. Now we're stuck here, and you can stop here if that's what you desire synthetically, but you still have an amine in the molecule. It hasn't been completely lost as trimethylamine. So you can do a second Hofmann elimination. Here's our second set of conditions, and take note, you must add all of these reagents again. You can't just say they're still floating around because this is stepwise. So from here, we'll get the nitrogen with a third methyl group and a positive charge, and the hydroxide. And now, once we heat that, now we only have the other beta hydrogen to choose from. So there's no regioselectivity to consider. We're going to use these beta hydrogen. The base will take one and eliminate. So we get the trimethylamine, and if you want to draw the water byproduct here, you can as well. This is a method to make a conjugated diene like you would use in a Diels-Alder reaction. It doesn't have to be exclusively used to make conjugated dienes, but that's what we ended up with in this case. And you will notice I did actually draw this alkene here as trans. And just stability-wise, the trans would be favored over the cis.